So moving on to the final topic about your definite integral. So this is still about definite integral, but we'll be dealing with um, a different kind of a definite integral. So we'll be dealing with improper integrals. So improper integrals, so this is the same process as your definite integral, but your limits of integration are infinite. So it may be negative infinity or positive infinity. And if we have these limits present in our definite integral, so we can call it as improper integrals. Now, on the other hand, is we have your multiple integrals. So I think this is just if you try to compare this one in your differential calculus, so you have partial differentiation, diba? So you get the partial derivative with respect to x, and then afterwards is with respect to y, and then with respect to z. So it's the same thing here, but it's partial integration siguro. You can call it as partial integration. So you'll be having multiple sigma or some equations or integral equations, and then depending on the order, so it may be dx, dy, and then dz. So that's why it's the super last topic, because I think it's an additional topic lang for the definite integral. So to start off, let's go to improper integrals first. So in improper integrals, we'll be dealing with two types of improper integrals. So we try to observe the limits of your definite integral to determine what type of improper integral that you're going to have. So we have two. So one is having the limit of infinity in your definite integral, or the other one is you have an infinite discontinuity in one of the limits. So let's try to discuss both, but we try to go to the infinite limit first. So for the different formulas presented on the improper integrals with infinite limits, so we have two. So the third one is just a combination of the first and the second one. So if you try to observe the given equation on the left side, so if the function of x is continuous on the interval a going to infinity, so we try to transform our equation. So take note that a is a closed bracket, so meaning it's included. Then infinity is an open bracket because we don't know when the infinity is going to stop. That's why it's parenthesis. Parenthesis against bracket. All right. So what we need to do here is we try to take out the infinite limit in the equation first. So we take it outside and we apply our knowledge coming from your differential calculus. So we're going to place it outside the integral equation and make it as the limit of the upper bracket, or the limit of the upper portion going to infinity, and then you give the equation. So what you did here is you just took out the infinity limit, and then apply your knowledge coming from your differential calculus by applying the limit of the certain variable going to infinity. And this will be applied later once you are done integrating the equation. All right, so I think it's super simple. So take note that the infinity was taken out the equation. It is now the limit of b, which is the upper limit, as b approaches infinity. So infinity is the given limit prior to the transformation. So the same goes for the second property. So we have the negative infinity limit. So again, negative infinity is an open bracket because we don't know what is our negative infinity value. So for b, the upper limit, it's a closed bracket because it's a fixed value. All right. So again, we take out the negative infinity outside the integral equation. And then since the lower limit is a, so we take again the limit of a as a approaches negative infinity. So this becomes the negative infinity. Then of course the a variable is coming from here. So again, we try to integrate the equation first before applying the limit of the infinity, whether it's negative infinity or positive infinity. So if you have negative infinity to infinity as your given problem, so you just have to divide it into two portions. So you can have negative infinity going to c. So most likely c is 0 because we can easily determine the values for your equation if the limit is 0. So usually c is equal to 0. And then transforming the equation, so for the first term you may use the second property, and then this one is you use the first property to transform it into these versions. Now for your improper integrals, so we're going to have two types of answers. So let's say you have evaluated your improper integral. So if the limit exists, it is called convergent, or your your improper integral converges, or in some books it is converging. So if the limit is not existent, so let's say the answer is negative infinity, infinity, so it's not an exact value, so we can call it as divergent or diverging, or the improper integral diverges. So converges, so the limit exists. So otherwise, if the limit is not existent, so it diverges. So those are the different properties. So let's try to solve some examples for us to appreciate what we have discussed so far. So you need to evaluate the integral of 1 over x from 1 to infinity. So again, the shown graph here is just for guide. So you may not necessarily graph the equation because sa given equation pa lang daan, we can already say that this one is an improper integral. Right, so improper integral because we have a limit of infinity on the upper portion. So again, as per property from the previous slide, so we try to take out the infinite limit first outside the equation. So that will be the limit of b as b approaches infinity. Then you're going to have the integral of dx over x from 1 to b. So you can now integrate the equation. So b is equal to the limit of b as b approaches infinity. Then this is going to be ln of x from 1 to b. So applying the limits, so as limit of b approaches infinity, and then you're going to have ln of b minus ln of 1. So if you try to calculate your ln1 in the calculator, so this will give you a value of 0. So what's left in the equation is the limit of b as b approaches infinity, ln of b. So I think you know how to evaluate this one coming from your differential calculus. So for those of you who have already forgotten how to apply this one, so try to put a very large number in your calculator. Let's say ln 9999999. So notice that it's a big number. So fill na ako 9, 1, 2, 3, 4, 5, 6, 7. So 7 nines. So this will give you approximately 16.12. So how about, let's say, ln 9? So it's only 2.20. So if you keep on adding large amounts of numbers, so notice that the value is increasing. So how much more if ln to infinity? So this will give you infinite number of answers. So this is equal to infinity. Then that's why this improper integral diverges, because the answer is non-existent. So this is divergent, or diverges, or diverging. And this alright, so simple na kayo, no? So questions for example number 1. So clear as the sky. Okay, so that's so if you try to sum up the steps in this example, so you take out the infinite limit, take out infinity, the next is integrate, then next is apply the limit of something as it approaches infinity, or it may be negative infinity depending on the problem. So this is the solution. So again, take note that this 0 portion here is coming from ln1. So let's go to another example. So again, take out the infinite limit. So this becomes the limit of b as b approaches infinity. And this is from 0 to b, e to the power of, sorry. So e to the power of negative x dx. So next is we integrate. So limit of b approaches infinity. So this will give us negative e raised to negative x. Then the limit is from 0 to b. So why is it negative e raised to negative x? So remember that the formula for the integral is e raised to u du. So let's say our u is equal to negative x. So du is equal to negative dx. So this becomes negative du is equal to dx. Okay, so that's why we have a negative sign on the limit. So applying the limits of integration, So the limit of b as it approaches infinity, then we're going to have for the first term that will be negative e raised to negative b, and then minus negative e, so minus and then negative e. So let's try to make this one clear by separating it with some brackets and parentheses. So bracket first, and then we're going to have the first term e raised to negative b minus e raised to negative 0, diba? There's no negative 0. So any number raised to the power of 0 is equal to 1. So meaning this will give us the limit of b approaches infinity, and then we're going to have negative e raised to negative b, and then minus negative 1. All right. So simplifying further is we're going to have the limit of b approaches infinity. So we can now simplify some terms by removing the parentheses. So this becomes negative e raised to negative b. So minus 1. This is plus 1. All right, so if we try again to apply the limit of b approaches infinity on the first term, so you cannot apply it on the second term because there's no b parameter there. So you only apply it in the first term. So let's say negative e raised to negative 9. So pila mo na pila value ana. So it's approximately negative 1.23 times 10 to the power of negative 4. So what if we try to make the exponent larger? So let's say negative 99. So negative e raised to negative 99. So approximately negative 1.011 times 10 to the power of negative 43. A super small number. So that's negative 0 point, how many zeros going to 1 pa dyan, diba? So how much more if you're going to plug in e raised to 999. So negative e raised to negative 999. So the calculator is already stating that it is equal to 0. Diba? So it's very small. So if you make it 4 nines, so it is still 0. So meaning the answer for this one is equal to, so the limit of b approaches infinity, so that will be 0 plus 1. So the answer is equal to 1. And it converges because you have an answer for your improper integral. So the limit exists. All right, so questions or clarifications? Okay, so there's no question. So CC kayo, no? So this is the solution. So moro dyan siya ang 3 steps. Kibalik-balik dyan na siya ni. So I think the problem here is you cannot use your calculator because you will be manually integrating things dyan kay you have a limit of a variable, di ba? So, kanisya, di ba? So I think the calculator cannot solve that one if you have variables as your limits. So let's go to another example. So again, take out the infinite limit. So this is going to be the limit of b approaches infinity, then integral of 1 to b 1 minus x times e raised to negative x dx. So I hope that you have not forgotten your techniques in integration. So since this one is algebraic, the other one is exponential. So you're going to be using integration by parts. So let u be the simple variable. Let dv be the complicated term but can be integrated. So complicated term is e raised to negative x dx. Then the simple term is 1 minus x. So getting the derivative of u, that gives us negative dx. And then v here is equal to negative e raised to negative x for the integral of dv. Right, so by formula, so we're going to apply now the formula of your integration by parts. So this gives us uv minus v du. So this will be the limit of b approaches infinity. And then you're going to have uv, so you have 1 minus x times negative e raised to negative x, right? And then minus the integral of v du. So this is negative e raised to negative x, and then du is negative dx. So if we're going to simplify things here, so this is going to be the limit of b approaches infinity. So trying to distribute here, so this gives us negative e raised to negative x, and then negative x times negative e raised to negative x. This will give us positive x e raised to negative x. And then triple minus, 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 and then minus. This will give you minus kyapon, di ba? Then the integral of e raised to negative x dx. So getting the integral, since this one is already simplified, so it's formula based, so we can integrate it completely. So b approaches infinity, and then this will give us negative e raised to negative x plus x times e raised to x, and then minus negative e raised to negative x, and then the limit is from 1 to p. So simplifying even further, so you have the limit of b approaches infinity, and then you're going to have negative e raised to negative x plus x times e raised to negative x. So minus times minus, this will give you plus e raised to x, and the limit is from 1 to p. So we can simplify even further by cancelling out these two terms. One is negative, one is positive. So what is left now is you're going to have the limit of b approaches infinity, and this becomes x times e raised to negative x from 1 to b. Then applying the limits. So you're going to have, for the first term, this will be b e raised to negative b. And then minus, second term is 1. That will be e raised to negative 1. So simplifying, let's say you don't want to see some negative exponent, so you can express it as b all over e raised to b minus 1 over e. Okay, so applying now the limit in the first term, because that's where the b variable is. So if you're going to apply the limit of b in the numerator, so that is infinity, and then in the denominator, so again e raised to a very large number will give you also an infinite number. Infinity po siya, di ba? So with this, so again, since it will be infinity over infinity, so the said answer for this one will be, I think, how do you call this in your differential calculus? There's a term there nga, if you evaluate the limit and then the answer is 0 over 0, infinity over infinity, so you need to use Hopital's rule. So how do you do this is, you're going to, so the function of x over the function of g of x, so you're going to derive the terms before applying the limit. So that is Hopital's rule. So just try to review this one. So I think you have this one in your calculus 1. So with this is, for example, this is our original term here. So getting the derivative of both, so this becomes 1 all over e raised to b. And then now we apply the limit. So the limit of b approaches infinity. So let me just properly state this one. So using Hopital's rule, so we now have a new format. So the limit of b approaches infinity, then you're going to have 1 over e to the power of b minus 1 over e. So 1 divided by infinity, so if you try to divide a very large number to 1, so it will give you a very, very small number, 0.000001, or most likely this will be equal to 0. That's why the answer is negative 1 over e. So again, if you try to look up the definition of Hopital's rule, so there's a statement there that if ever the evaluation of the limit will give you 0 over 0, or let's say infinity over infinity. So I think the correct term for that one is you're going to have indeterminate answers. So mo siguro na ang proper term na. So if you're going to have 0 and then if you're going to have infinity as the answer, so I think that's what the term is. It is called indeterminate answers coming from the evaluation of the limits. So to avoid those indeterminate limits or indeterminate answers, so we're going to use Hopital's rule. And then again, by definition of Hopital's rule, so we're going to take the derivative. So I think the correct formula for this one is, if ever, let's say, x approaches, let's say, a, and then, so this is integral, but so if the limit of x approaches infinity, and then f of x, then g of x, so if it's going to give you 0 over 0, or let's say infinity over infinity, so you're going to use L'Hopital's rule, and the formula is this one. So x approaches infinity, f of x over g of x, and then through the use of L'Hopital's rule, so this is the formula. So the limit of x approaches infinity, then we're going to take the derivative of the function of x. You're going to take the derivative of g of x, or in simple terms, you're going to differentiate the numerator and then the denominator. So muna siya, to make the long story short. So just derive the numerator and then the denominator. So that's what the L'Hopital's rule is all about. So inyo muna siyang excuse. So you're just going to derive the numerator and then the denominator. Okay, so this is the simplified solution. So this is coming from the reference lang. So muna, if maglibog mo sa mga references na inyong studyhan, so try to go very basic, or try to solve it step by step, so that you will know where the terms are coming from. So notice that this one is the derivative of b, derivative of e to the power of b. So that is L'Hopital's. All right, so questions, clarifications. So there's no question, so let's proceed. So this is an example of the third type, wherein you're going to have two infinity limits. So taking both outside the equation, so you're going to have the limit of a approaches negative infinity. Then you're going to have, before that is we're going to split this one into two portions. So this becomes negative infinity going to 0, e raised to x all over 1 plus e raised to 2x, then plus 0 to positive infinity, e raised to x over 1 plus e raised to 2x. So we can now take the infinite limits outside the equation. So this becomes a going to 0, e to the power of x over 1 plus e raised to 2x dx. Then the second term is you're going to have the limit of b as b approaches infinity. So that will be 0 to b, and then e raised to x 1 plus e raised to 2x dx. So since both terms are the same, so you can try to evaluate the integrals separately. So you may do this in this format. So integral of e raised to x over 1 plus e raised to 2x dx. So notice that this one is in the format of a squared plus u squared, which is in the arctangent formula, inverse tangent formula. So if you have forgotten the inverse tangent formula, so the formula looks like this. So du all over a squared plus u squared, and then this will give you an answer of 1 over a arctangent u over a plus c. So we're not going to put plus c because we are evaluating integrals with limits. Okay, so a squared is equal to 1. So let's try to put it on underneath the kuan lang equation dyan. So a squared is equal to 1. So a is 1, getting the square root. So u squared is equal to e raised to 2x. U is equal to e raised to x. And then getting the derivative, du. So it is e to the power of x dx. So notice that every term can be replaced in the equation. So that's why you have this answer here on the right side. So simplifying is now we have 1 over 1 arctangent e to the power of x over 1. So to make it simple, so this is arctangent e raised to the power of x. And that will be your integral. So going back to the limits, so this will now give us the limit of a approaches negative infinity. So this is arctangent e raised to the power of x, and the limit is from a to 0. Then minus, plus rather. So the limit of b approaches infinity, then this is arctangent e raised to x from 0 to b. Okay, so limit of a approaches negative infinity. So this is arctangent e to the power of a and then minus arctangent 1. So e raised to 0, that is arctangent 1. And then plus the limit arctangent 1 again there. So e raised, did I say up there? So this is, so nangabalay na akong mga terms. Wait sa, atong spontanan kay upper limit mo ni nauna there. So the first one is arctangent 1 and then minus so the limit of a approaches negative infinity, arctangent e raised to a. So that will be coming from the first term. Then plus the limit of So this is the limit of b approaches infinity, arc tangent e raised to b, and then minus arc tangent 0. Okay, so my suggestion here is if you try to plug in arc tangent 1, so it will give you 45, diba? So on the last part is 1 po day. So ano man sige ta kasayop. So this is 1. So if you try to plug in arc tangent 1, so this will give you 45. So this is degrees, diba? Okay, we are in degrees mode. So this is 45 degrees for arc tangent, diba? If we try to get the angles for our, let's say, triangle, so we use the inverse functions, diba? So arc sine, arc cosine. So instead of getting angles for your answer, muragbati kay tanawon because we're not dealing with degrees here in the limits. So try to shift your mode in your calculator to radian. Then if you try to evaluate again arc tangent 1, so this will now give you pi over 4. So again, this is degrees mode, this is radian mode. So this is 45 degrees, or in radian mode, this is pi over 4. So arc tangent e raised to negative infinity, so e raised to a very large number, very large negative number, will give you 0. So arc tangent 0 is also 0. So this one is 0. So how about for the arc tangent e raised to a very large positive number? So let's say e raised to 99. So murag, I think mura siyang limit sa calculator, because if you try to plug in e raised to 3 nines, so it's going to be math error na. So meaning it's super large. That's why math error siya, di nakakasolve ang calculator. So if you try to plug in e raised to 99 and then arc tangent e raised to 99, so this will give you pi all over 2. So that is again in radian mode. So if in degrees mode, so if we're going to plug in arc tangent e raised to 99, so the answer is 90, diba? So again, this is degrees, this is radians. So again, since we're not dealing with degrees in the problem, so we try to go to radian mode. So simplifying things now, so let me write it on the upper graph lang, sa upper left. So you're going to have pi over 4 minus 0, and then plus pi over 2 minus pi over 4. So simplifying things further, so by removing the brackets, pi over 4 minus 0 plus pi over 2 minus pi over 4. So cancel out, cancel out, cancel out. So the answer is pi over 2. And then this one is converges. So ipakita ninyo ano kuan siya. Ano 0 siya. So for example, e raised to this, for this portion, you're going to plug in e raised to a very small number. Then arctangent. So provide evidence as much as possible for your answers. All right, so question or any confusion regarding the problem? Right, so sayo no? Magmadugi lang ta sa pag-integrate. So this is the answer. So again, this is coming from the reference. That's why it's super simple lang. Bali, puro na siya shortcut iyahang ibang buhat. Okay, so those are for the infinity limits. So now we go to the infinite discontinuities. So to start off is the definite integral will be improper if one of the limits is discontinuous. So meaning, let's say the upper limit, so let's say for the first property, the upper limit will give the, if you try to evaluate the given equation, so it will give you 0 or it will give you an undefined value for the function, diba? So muna siya. So that's why notice that B is an open bracket. So meaning B is not included, but to the left of B, so all of the values from A, so notice that A is close bracket, so meaning A is included in the limits. So if you try to think of this one in the algebra concept, so you just have to draw the number line. So diba, I think namuha ni sa inyong algebra, so let's say this one is 0, this one is say 1, 2, and then 3. Then -1, -2, and then -3. So if you try to create the range for your items, so let's say, diba, if open dot, that is 1, diba? It's an open-ended range, and then if it's a solid dot, so meaning ana apil ang 2 sa inyong range. So if you try to write it in algebraic terms, so this becomes -2. So notice it's a parenthesis, and then going towards the 2 portion. So since 2 is included in the range, so we're going to put a close bracket. So murag-mura po na siya ang idea behind this discontinuous improper integral. So let's say B is the discontinuous limit. So taking out B, then you're going to have it as the limit of C approaches B minus. So why it's B minus? Because you are taking the limits on the left side of B only. So notice that we are going from A to B. So mura siya going from left to right, diba? So if you take out B, so and then since B is not included in the range for the limits, so that's why you try to plug in B minus, meaning that all of the values on the left side of B will be included in the evaluation of the limit. So mura na gyapon siya infinite limit, but since you have a fixed value for the upper and the lower limit, so let's say ang inyong upper discontinuous limit will be 8. So since the limit is talking about B minus or the left side of B, so you can plug in 7.99, diba? So it's still on the left side of 8. Or you can plug in 7.8999, so it is still on the left side of 8 as long as it is not equal to 8 para maka-evaluate mo sa inyong limits. So let's say the lower limit is now discontinuous. So again, since we are going from left to right, so notice that the limit of A is now on the right side, so it's A plus. So everything on the right side of A is included in the limits, excluding A. That's why if you try to read the statement, so A is an open bracket, B is a closed bracket. So for the third one, it's just a combination of the first two. So that's the same as earlier. So you can try to split it into two parts and then evaluate the discontinuous improper integral. So it also has two types of answers. So if it exists, it converges. If it's not, it diverges. So mura dyan na siya. So kato ganina, so if you try to think of it, so murag the same na gyapon siya, but when we try to evaluate our infinite limits, so we try to make our infinite limits as positive 99999, and then for negative infinity, negative 9999999, di ba? Mga ito ipang-plug in sa itong equation. But for this time, since the upper and lower limits has definite values, so for example, the lower limit is now, let's say, 0. So if you try to plug in the equation or evaluate the limit later on, so you may use 0.000001, di ba? This one is still on the right side of 0, as long as it's not equal to 0. Alright, so let's go to an example. So in the given equation, so at first glance, you may not notice that this particular example is irregular definite integral or improper integral as per visualization, di ba? So, initanaw ninyo, ay, kung ano siya, it's a regular definite integral. So, I can just use my calculator. And then once you use your calculator, so, what happens is, kuan siya, mura siya mo math error, di ba? So, math error ang answer if you're going to use your calculator. So, meaning this one is discontinuous. So, the problem next, so since you know that this equation is an improper integral because the calculator cannot solve it, so the next difficult step is which limit is the discontinuous portion, the lower limit or the upper limit, diba? So marwata ka ba asa ang discontinuous limit? So my tip here is you're going to plug in 1 in the given equation and then plug in 0 also in the given equation to see or to evaluate which limit is the discontinuous limit. So let's say I'm going to plug in 1, so this will give me 1 all over cube root of 1. So this will give me 1 over 1, which is equal to 1. So meaning the limit exists, diba? So what if I'm going to plug in 0? So 1 all over the cube root of 0. So cube root of 0. So if di mo sure on say cube root of 0, i-calculator ba jud? So that is 0. So this is 1 over 0. So any number divided by 0 is not 0, it is undefined. Diba? So meaning the lower limit is the discontinuous limit. Discontinuous. So we need to take 0 outside the equation. Alright? So to do this is we take this one outside. So the limit, so take note that the lower limit is a. So as a approaches 0 plus, diba? So di na siya infinity. So na siya value, diba? 0 plus meaning the right hand side of 0. So from a to 1 and then dx all over the cube root of x. So we can evaluate this one by making it in exponential expression, meaning in exponent terms. So 0 plus, then this is from a to 1, and then we're going to have x raised to negative 1/3 dx. So n plus 1 over n plus 1, 1 plus 1/3, negative 1/3 plus 1, that is 2/3. So this will give you the limit of a approaches the right hand side of 0 or 0 plus. Then this is x raised to 2/3 all over 2/3, and then from a to 1. So simplifying further, you have the limit of a approaches the right hand side of 0. So you have 3 halves. So 3 halves, and then x raised to 2/3 from a to 1. So the limits of integration first. So this will give you the limit of a approaches the right hand side of 0. So this will give you 3 halves, 1 to the power of 2/3, and then minus 3 halves, a raised to 2/3. So evaluating the limit now on the right hand side. So let's say 0.00001 raised to 2/3. So it will give you a very small number. So let's start off with Guana. So let's try to plug in. So 3 halves. So negative 3 halves. 0.01 raised to 2/3. Then you try to evaluate. You try to evaluate that one using your calculator. So raised to 2/3. So the value is negative 0.07. So if you try to make it smaller, so let's say 0. Let's say 10 zeros. 1, 2, 3, 4, 5 lang sa. 5 zeros lang sa. So negative 3 halves, then 5 zeros, then 1. So raised to 2/3 again. So the value is approximately negative 1.5 times 10 to the power of negative 4. So super small na kayo siya, di ba? So what if super large ng number na po? Let's say 10 zeros. So it even gets smaller. So with 10 zeros, it is now negative 6.96 times 10 to the power of negative 8. So if we even go further, so as long as it's on the right side of 0, so the value for your equation is equal to 1 gapon siya, 0. So, di ba, it gets smaller, di ba? The trend is getting smaller. So we can say that the right hand side limit of this one is 0. So we can simplify it by 3 halves minus 0. So the answer is 3 halves. All right, so questions or clarifications? Okay, so none. Let's proceed. So this is the solution there. So next again is this one here. So aside from using your calculator, so you can already tell that this one is discontinuous because you try to plug in 0 in the equation. So this will give you undefined value, di ba? 1 over 0 cubed, this will be 1 over 0, so this is undefined. So for the upper limit, so of course, if you try to plug this one in, this will give you 2 cubed, this will give you 1/8. So this is a definite limit. So discontinuous limit, so so the limit of a approaches the right hand side of 0. So this will give us a to 2 dx all over x cubed. So making it in exponential expression. So this becomes x to the power of -3 dx. We're going to have the limit of a approaches the right hand side of 0. So this will give you x to the power of -2 all over -2. So from a to 2. So the limit of a approaches 0 plus. So this is -1 all over -2 x squared. So ako na siyang i-transfer sa denominator. So puro siya negative. So daghan na kay negative sign, no? So let's try to eliminate the others. So that will be from a to 2. So evaluating the limits of integration first before the limit. So this will give us -1 all over 2 times 2 squared. And then minus. So nawa ang limit, no? So ato ibutang ang limit pe. So pwede na po siya day. Then atong i-distribute lang to the proper term. So minus the limit of a approaches 0 plus. So this is -1 over 2a squared. So the first term is -1 over 8. Now for the second term, so again, you have to try some examples here. So -1 over 2 times, let's say 0.01 squared. So what will be the answer for that one? (0.01 squared). So that is -5,000, di ba? Sakto ba? So this is -5,000. So if you try to plug in, let's say 5 zeros, so 1 over 2 times 0.00001 squared will give you -5 times 10 to the power of 11. So meaning it's a super large negative number. So the trend is increasing. So it is an increasing negative number. So you may try to put it as negative infinity, di ba? So going towards negative infinity siya. So minus negative infinity. So minus infinity. So this will give us -1/8 plus infinity. So taking -1/8 from infinity, So mura ra kag nanggitik ana sa infinity, di ba? Mura nang gigitik ang infinity. Kuha ra kag gamay nga portion sa infinity. So the final answer is infinity. All right, so that's for the second example. So questions? Okay, so none. Okay, so this is the answer or the solution. So again, the solutions presented are just simplified because it's coming from a book or katong reference na akong igamit. Okay, so since we're running out of time, so just try to evaluate example number 3 on your own. So this is the solution for number 3. And then for number 4 this is the number 4 item. So just try to pause this one as you review the recording. This is the answer. It will be pi. So again, the solutions are in shortcut mode because it's coming from the book. So kung nagdili kay siya nindot tanawon kay magic lang ba. Okay, so this is the problem set for the improper integrals. So again, I'm not going to give this one to you, but this will serve as your review materials. So you can try to solve this one on your own, and then those are the answers. All right. So lastly is we go to multiple integrals before we dismiss. So in multiple integrals, so again, it is just the same as partial derivatives. So you are partially integrating in this part of this course na lang, di ba? So last time you are partially deriving with respect to a certain variable. So this time is you are partially integrating. So the technique here is you're going to solve the inner portion first, so meaning dx first, and the next is the outer one after evaluating the first integral. So evaluate the next integral with respect to y this time. So if you try to evaluate x first, so notice that the first term don't have an x, second term has x squared, the third term don't have the x variable. So integrating is you're going to have from 0 to 6, then integrating the terms above. So you are going to have 27x minus x cubed over 3 minus 1 half x times y squared. So notice that we ignored y because we are integrating with respect to x. So of course it is at this point it is valid because again we are partially integrating. So that's why we can now have other variables present in the equation. So, di na siya strict nga dapat mura dyan na siya ang variable present in the equation. So, the limit is from 0 to 3. And then dy. So, evaluate first before getting the integral of dy. So, this is going to be from 0 to 6. And then 27 times 3. Then minus, we're going to have 3 cubed over 3. So let's try to erase lang and then minus 1/2 times 3 times y squared. And then minus. So since the right side is 0, so pwede rin niyo mo ignore ang 0, di ba? 27 times 0 is 0. Or pwede po nyo, if ganahan nyo ipakita, pwede sa din nyo ipakita sa na 0 minus 0 minus 0. But pwede rin how dili good kay 0 na siya, di ba? So from 0 to 6. So this becomes, so again, this one is 0. So what remains now is 27 times 3, that will be 81 minus 9 minus 3/2 y squared and then dy. So 81 minus 9, that will be 72. So you're going to have 72 minus 3/2 y squared dy. So at this point, you can now use your calculator because you're now integrating to one variable. And then the answer for this one is 324. So nanas calculator. So manapaspas kayo nanas calculator na. Alright, so that's the answer for that one, and this is the solution. Okay, so for the last part is this one. So common lang solve siguro, no? Para fun. Nasa mo extra problems pod na i-solve sa practice problems. And then this will be the solution. The answer is 5. And then for additional items for you to review, so this is the problem set that I was going to give, but ilan ako ihatag, so you can take it as your review materials. So those are the answers as well. So again, the variables may not necessarily be in alphabetical order. So as you can see, you'll be integrating with respect to z first, then y, and then x, diba? X, y, and then z. So napoy other this, diba, dy, dx, and then dz. So dili siya dili siya necessarily in alphabetical order. So questions or clarifications?